equals PR, you divide by R, and you get X equals P, which is what we want. You follow that or not?
Yeah.
Okay, now you do the same thing for the second one. Rx equals PR. Well, it's exactly the same. You divide by R, X equals P. Is that okay?
Yeah.
All right. So the last two are problematic. So that's, that's A, that's B. So C says PX equals minus PR. When you divide by P, you get X equals minus R, which is not what we want. Same thing for the last one there. For D, you get PX equals PR, divide by P, X equals R, like that.
Got it.
So we're down to A and B. Okay. Now, I've kind of messed up this question, but I'm going to reframe it here. And we're down to first two here. Now the y-intercept is when X equals 0. So this time you're covering up the X terms. So between these two, minus PY equals PR and PY equals PR. When you solve for Y, one of them will be 4, will be R, sorry. One of them will be R. So for example, on the left here, you're divided by minus P. On the right here, you're dividing by P.
So it gives you R's. Yeah, it gives you R on this would be
So which one gives you R is really what we're trying to figure out here.
it'd be PY equals PR because
Yes,
other one would
gives you
be
negative R.
negative.
So that tells you that it must be the second choice there.
Got it.
This is actually a really good SAT question. It's not difficult. It's just you have to be willing to manipulate letters instead of numbers. And that's what a lot of the SAT questions are like. They give the appearance of being difficult. They're obfuscated.
Got it. All right. Let me put that from here into the chat.
Okay,
Right,
you
the
dropped
next
another
one.
one there.
Yep.
Right, so for the line segment whose endpoints are 1, 2, and 6, 7, find the x coordinate for the point located 1/3 the distance from x to y. So the distance from of the x coordinate is 6 minus 1, which is 5. And then you're taking a third of that. You're taking 1/3 of 5, or 1/3 times 5, which is 5/3, or 1.7-ish. And then you're adding it to the x value. So you're taking the old x value of 1 and adding this new x value. So I get a different result here.
Oh God. I kind of looked at what looking at what you did. So 1/3 times 5/1 is you get the 5 from 6 minus
I'm
1.
gonna put you in a brief just pause here, Karthik, but let's go over to your next questions. I'll be right back.
Right.
All right, Karthik, I am back. Apologize for the delay. It's kind of a continuation from the other day. What's been going on in my life? Let me know when you're there. We got number 12 in front of us.
Yep,
All
number
right.
12.
So Annie is creating a stencil for her artwork using a coordinate plane. The beginning of the left edge of the stencil falls at 2, -1. She wants to align the more important because our stencil at 4, 1. She knows this is 1:4 of the way where she wants to end the stencil. Okay. All right. So the thing that this one reads awkwardly is which is the end, which is the start. Okay, so the beginning, where she, okay, so the beginning is 2, -1, and then 4, 1. So the X value here is 4 - 2 is the distance, which is 2. And then we really want this 1 to 4, and maybe I'm starting to see why there's been issues, but this 1 to 4 means 1/5 of the way, which is 0.4 of that. Sorry. So it's 2 times 1/5, which is 0.4. But you see, that's not there. That's not there. Maybe your book, I mean, I'm sorry we've done this so many times, but maybe your book actually means something different by this. Maybe that means 1/4.
Yeah,
And that might,
that's what I even usually using is one
okay,
fourth
so
one number.
so that's incorrect in terms of the way that this is like standardized, but that's where I've been maybe giving you some bad information. So 1/4 of the way, 2 times 1/4 of the way is 1/2. And you take that 1/2 and add it to 2.
So 2.5 and
2.5. And so we would do the same thing to go from 1 to -1 is also 0.5. Now that means we might want to go back and look at some of the ones we were doing earlier. And that might have been why there was this small disparity between them. But it's up to you. I mean, I think we're close enough. You probably weren't gonna be off. Like I was still gonna have you choose 2.5 here because, well, it's it's the one that's closest.
all right. All right. Um, number 13 in the chat now.
Right. What is the area of trapezoid DEFG? All right, so to find the area, uh, one approach is to use the trapezoid area formula, which is 1/2 base 1 plus base 2 times the height. But that presumes you can get that information from this. And I actually think you can if you make a quick sketch of this. So let's just say the origin is there. 2, 3 is there. 5, 3 is there. 3, 1 is there, and 2, 1 is there. So this is the trapezoid. So the bases are parallel. So that's base 1 and that's base 2. So we actually have all the information we need for this. All right. So is that clear from the sketch what I've done
Yeah.
or not? I mean, you can go to Desmos and graph this, but I mean, you can also just I've got the nice grid paper here, so you can do it. But you can see that base 1 is 3 units, base 2 is 1 unit. The height is 2 units.
Okay. Then you just plug it into the
And you just calculate it.
4 times Yeah, 4 square units.
Now, if they weren't nice, like we would have to calculate using the distance formula, the length, and the heights, but we had all that information there.
Here, let me put number 14 in the
Okay.
chat.
And
Pretty
just be careful. I mean, we're not quite halfway through our lesson, but maybe it's maybe in about 10 minutes, 15 minutes, start prioritizing stuff. That way we get everything done that you want.
Yeah, number 14 is really similar to number 13. It's just for a triangle and using the altitude it give the height of the triangle instead of the given height of the trapezoid.
Okay.
Should think and do that. All right, this one is one that I wanted to go over. I put it in the chat. Because it's not exactly a perfect triangle. The number 15. Okay, it's in the chat.
Find the perimeter of the shape. So we did this yesterday, and I recommend we're basically got to find the distance from A to B, B to C, C to
Oh
D.
yeah, right.
Okay, and
Forgot.
actually looks pretty similar. But having said that, I mean we'll do it here. I prefer when it's graphed, I prefer the triangle approach, which is making a right triangle
Yeah,
and
because what I
calculating
was
the
trying to do is trying to find the parameter of the two different triangles and then adding it together, but
yeah
that would
that
still require
you're
the
making more
distance
work for
formula.
yourself. Yeah. That's okay. I mean, sometimes you just need to have someone show you the shortcut here. When if you go into work in engineering, sometimes you have these brainstorming meetings and something that looks really complicated to you, someone else comes up and just says, "We'll just do this." And it's never, I mean, you're not talking about triangles, but they'll just say, "Why don't you just do this?" And you're like, "Oh, because they've been staring." The issue is you've been staring at it for so long, you don't realize that there's other solutions, and people with a fresh perspective will be like, "Yeah, just do this." You're like, "Oh, okay." So let's go C to D. Same thing here. You got 7 squared plus 2 squared, and A to D. You got 6 and 4, like that. I'll just leave it up to you here to calculate each of these and add them up. See what you come up with.
15 for AB. Two squares. A square root of A square root of 15. A square root of 3. A, B, F. So in this case, if I get a decimal, would I just round it to the nearest whole number?
I mean, I would go to 1 decimal place for each of these.
All right.
That'll probably, get you close enough.
All right. So let me just simplify the square roots real quick, really quickly. Where, yeah. Three. All right. So how wanted it be decimals, and I got. Let me just add them up. 3.9 plus 2.8. All right, I got 16.1.
Well, um. Okay. Like this one is the square root of 17. This is the square root of 8. This is the
Oh,
square root
the
of
first one
53.
I put square root 18 back, or square root of
Okay.
15. I think
I mean,
that's
it,
what it.
I mean, if I'm just sort of guessing, like that's 6, that's 7, that's 13, 5. I mean, it's probably this first one, but it concerns me that we're not getting close to the right answers here.
Just see something quickly. Four point one, so 0.1, 2.8, 3. Oh, even once I changed that, I still got 16.3. Or I got, yeah,
Let's
now I got 16.3.
let's go with that one. It is that
Yeah,
one, and maybe I made a mistake too somewhere writing some of this down, but um, yeah. So
all
whenever you're
right.
ready, if you want to drop another one in the chat here,
Yeah,
and
let me just pull it up. So this one is the first one in, actually, 1 second. Let me grab. All right. So I'd actually like to go over this. This is the pre-test for module 5. On the
mhm.
pre-test, they did talk about sin and here, let me just show you. So this is number 1. Did I not name this? This is the pre-test, so this is number 1 in the chat now.
Okay, so this is totally new here. Um, so sine of an angle is the answer is a ratio of sides. And there's this language that you may have seen in other courses. So ka Koa. So Katoa. Have you ever seen that before? Heard that before?
Really?
No? It's okay if you haven't. I'm just asking. So the sine of an angle is the opposite side over the hypotenuse. All right. So like imagine you're
Oh,
standing there. The opposite to you is right there. That's the opposite.
got
It's
it.
almost like the word like a cross would be better. And then hypotenuse, well, there's only one hypotenuse. The hypotenuse is always the longest leg.
Got it.
Okay, so it
Yeah,
must be
okay,
in
that
this
makes so much
case
sense.
5/13. So these are all written poorly. They should be formatted this way. I don't know why they can't I don't know why they can't do that, but it's bad formatting.
Yeah, I can now understand why it would be 5/13, because 5 is the opposite and 13 is the hypotenuse. Got it. Yeah, that.
So I almost feel like I should go into a little bit of explanation here, but there's three trig functions that you have to know for sure: sine, cosine, and tangent. There's actually six, but these are the main ones. And that's where this so katoa thing comes in. If you have no idea what I'm talking about, let me know. I just keep I'll pull up a reference here for you. So all right, so here is what sine, cosine, and tangent refer to here. Opposite over hypotenuse, that's the so. I like to write it this way: SO over S to O over H, because the O means opposite over the
Oh, yeah, I can
hypotenuse.
see that now. Yeah.
Is CA over H. Koa is tangent is opposite over adjacent.
Got it. Oh, yeah, so, yeah, got it. So then sin is opposite over hypotenuse. Cos, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Adjacent being the side that's right next to it.
Yeah, so it depends. So like it depends on where you are. So you're at A versus B, opposite is different. So from A, the one across is opposite, and the one here next to it is the adjacent. But if you're at B, the one across from it is opposite, and this one over here is the adjacent.
Got
But the
it.
hypotenuse is always the hypotenuse.
Yeah, even if even if it's like you know where you put the 90-degree angle down there, even if that was the point, that and then the hypotenuse is the opposite as well, would it still be the hypotenuse? Like if you're looking at the point where the two lines are perpendicular at 90 degrees,
If
and then
those are the
that,
legs.
yeah, so then if the hypotenuse was also, can the hypotenuse also be the opposite?
Well, the hypotenuse is always the longest side.
Got it.
Right. But the legs are what switch between adjacent and opposite depending on perspective. It's like when you're sitting around a table. If you're here and your dad's there, he's across from you. But if you move over here, he's now adjacent or next to you.
Got it.
So it really depends on your perspective.
Got it. Yeah, that makes more sense now why it would be. 13, because 5 is across from the x, or opposite of the x, and then 13 is the hypotenuse of that triangle. All right, so the next one there. All right, number 2 is in the chat. Yeah, because before taking this, obviously I haven't really seen like sine or cosine. Like
So you're right here. You're physically there. Sine of that angle is the opposite over the hypotenuse. Now I draw a little human so you can, it's like imagine you're standing there like that's opposite, that's the hypotenuse. There's
got
really
it.
no
So
math. It's like it's almost like I don't know, vocabulary thing.
this is one that kind of confused you a bit. So let me put it this one other one in the chat. Kids in the chat. This one's a bit confusing though.
All right, if tangent x equals a over 4 and cosine x equals 4 over b, what is the value of sine x? So that what they're doing is they're telling you that tangent of x, which happens to be opposite over adjacent, is a over 4. They're telling you when the given that the opposite is a and the adjacent is 4. So relative to x again, the opposite is a and the adjacent is 4. They're giving you the values rather than like you finding out what the tangent of x is.
Uh, so then what is number 4 saying? 'Cause it says sine.
Okay, we're gonna get to that. I just want to make sure that was okay. Now the next part, cosine of x, cosine is the adjacent over the hypotenuse, and they're saying that's 4 over b. Again, right here, the adjacent is still 4, that can't change, but the hypotenuse is b.
Okay.
All right, so now sine x, which is
Oh wait, that's the opposite.
over the hypotenuse, you
Yeah,
now
got
have the
it.
3 sides. Well, it's a over
Yeah,
b.
that makes sense now.
There's a good thing though about you trying these. I mean, what you're learning by trying them, you can't get unless you fail, basically, for lack of better word. Fail, fail, fail. You learn more through your failures than your successes, truthfully.
Okay. Um, one second. Let me scrap the next. This one. Uh, all right, it's in the chat now.
I see you sent that over. Oh boy, okay. All right, so all right, yeah, this is they really jump right in this. Okay, so sometimes it's better to just draw a triangle without all the pictures stuff going on. I mean, it's great that there's a tugboat and or a boat and a yeah, whatever. But the the height of the lighthouse is 64 meters. That's this one right here. And the angle is actually given as 43 degrees. Now, kind of off to the side here is that this right here is the angle of elevation. And the angle made with the horizontal, this is the angle of depression. Okay. And they happen to be congruent. If you're ever unsure, they are congruent. So the they're calling the distance between the boat and the base of the lighthouse. And the base of the lighthouse right there. That's Z. From the boat to the base of the lighthouse, that's Z. And they want to know which of the following can be used to find Z. So what you do to answer a problem like this one is you imagine again that you're there. You're there here and you say, well, what do I have? What is 64? And the answers are it's adjacent, opposite, or hypotenuse. So what do you have? Is 64 the adjacent, the opposite, or the hypotenuse?
64 is the opposite.
It's the opposite, okay? And then what you're trying to find Z, is that the adjacent, opposite, or hypotenuse?
That's the adjacent.
It's the adjacent. So now the question is, which trig function uses the opposite and the adjacent?
It obviously isn't, it isn't sine. It has to be tan.
It's tangent. I mean, we have the answer there, but that it's the tangent of 43 degrees equals the opposite over the adjacent. And now you have those. The tangent of 43 equals 64 over Z.
Got it. All right. This before I listened to it did end up going through like the first lesson, just kind of seeing what it was about. Um, it did end up going to their lesson material for the first lesson. But I still had some questions on it. That's why I wanted
Sure.
to
Yeah.
go back to the pre-test and review that before taking this test. Let me put first question. I don't know, we probably won't finish this in this session, but we can probably get started with it. So this is number 1 in the chat now.
Right. Find the sine ratio of angle theta. So this is a Greek letter here, theta. There's a whole Greek alphabet. You can go to Wikipedia or go to the internet and find things. But that sine of theta. So the sine of theta is the opposite over the hypotenuse. So again, just like all the other times, until you're really comfortable with this, like I don't do this, you won't do this at some point. But imagine you're standing there. What's opposite to you? What's adjacent to you?
Oh, so kind of like the thing that we were going over right now, where it was about
Exactly.
So you just had to put like the ratio in a fraction form of the opposite over the hypotenuse, which in this case would be 12 over 13. Got it. Uh, think, mm, no, backline, that's for this other one. But this next one that's in the chat, it talks about cosine of the theta. It's adjacent over hypotenuse. That's what it was for cosine.
Cosine is adjacent over hypotenuse.
Yeah, I think I just also, yeah, the question that I was talking about is in the chat.
Oh, it is. Okay, I'm sorry. I thought
Oh yeah, I forgot
thought no, I thought they
it.
looked the same. I was like, what the, like I didn't all right, sorry, yes, cosine of theta is the adjacent over the hypotenuse, and the adjacent is 8, and the hypotenuse is 17.
If you could scroll up a little bit to the example that you had before, where you
Yep,
had B as one of the points, like a little bit more up.
here.
I think it's a little bit more up. I think it
Wow.
was like number 2 or 1.
Yeah,
Maybe it was question number 1. That was the. Oh yeah, here. That was right there. Right there
this
we
one.
go. Where it was a little bit here. Just scroll up a little bit. All right, right there in the corner, where you had point B as one of the
Oh, I
examples.
see.
Yeah.
Yeah,
Why wouldn't the hypotenuse also be one of the adjacent?
the hypotenuse is always the longest side, and it's
So
always
the
across from the
hypotenuse cannot
90.
be the adjacent. Cannot.
Never, never, and it's always across from the 90.
Got it. Yeah, that's one thing I was kind of confused. That's why I was wondering why the hypotenuse couldn't be one of the adjacent sides.
Yeah, that's the way they should start it. They should say the hypotenuse is always the longest side. It's always across from the 90, and you should have to sit there and identify hypotenuse over and over and over again until you have it down. All right, we might have time for another question. If not, we could close out here. Let me know if you think you've got one that's pretty quick for us to look at next.
Um, we can look over this one. Usually I'm able to snip it. There it is. All right. All right, it's in the chat now.
All right, there it is. All right, if the sine of angle X is 4/5, and the triangle is dilated to be 2 times as big as the original, what would be the value of sine X for the dilated triangle? Here's the reality. So let me draw a triangle. There's X, that's 4/5. So here's what they're saying. They're saying it's now 8 and 10. All right, so if sine X here is 4/5, on the right, it's 8/10, but what does that reduce to?
Favorite 10 would reduce to 4/5.
So the triangles always reduce down to their lowest possible form.
Would be the values. Divided. So it would, so it'd still be 4/5.
And that's the point. Is it still 4/5? I guess what they want there.
Got it.
All right, we do have to stop there for today, but we got a lot done.